Hi, welcome to this third part in chart design. In this little short video, we're going to talk about pie charts, bar charts, and scatter plots. These are the types of charts that that we usually see in capstone presentations and in research reports. So I think it's a good idea to talk about them, applying the two principles that we've discussed in this video series, talking about chart efficiency and chart integrity. So let's start with pie charts. Pie charts are only used to present relative frequencies. That's what they are for. The slices of the pie are supposed to show the relative frequency in terms of size, right, of a group. So the principles of chart integrity and efficiency apply to the design of pie charts. Of course, you need to avoid using pie charts when you have too many categories, right? When you have 20 categories in a variable, you should avoid pie charts because they're not an efficient way to show the data. You should consider using a table instead. So use pie charts when you have a relatively low number of categories, and also avoid using pie charts when one or more categories have a very small relative frequency, right? In these cases, you should consider using a table instead. When you use a pie chart, always label the values, right, in the slices, and add the relative frequencies, add the percentages there. That's what they're showing. The graphs, pie charts are showing relative frequencies, so they should have the relative frequencies there in the label, so that people can easily compare them. Sometimes when you have when frequencies are close, it's hard to tell from the pie slice, from the size of the pie slice, which one is bigger. So always label them correctly. I'm going to show you an example here that it unfortunately happens too many times. It's far too common. You come by a chart like this. So this is a 3D pie chart, and its label is a distribution of respondents' race, and you have something like this, right? You have many repetitive things going on, a lot of chart junk, right? A lot of chart junk. That's a lot of ink there to show this distribution, right? You see here double labeling. You have all these labels, and the labels are again in here. So that is repetition. All these patterns are very tiring on the eye. You should avoid them. Now look here, American Indian category and Alaskan. Those are very small. They should be avoided. You have some lines there that are crossing the numbers. You have two labels on top of each other. That's a very, very poor design of a pie chart. When you have this 0%, 0%, they should have gone on a table. Actually, these data should have gone on the table. But if you must use a pie chart, you can consider something like this, right? This is the same data that we saw before, right? Other 6%, white 72%, black 22%. We have no other junk around. We took all the ink from that 3D, awful 3D pie. See all that, and when the slices are out, it's just very poor design. A lot of junk on that one. If you must use a pie, avoid the 3D, and avoid those very, very small categories. Either put these together, right? Or if you're interested in showing all the categories, use a table instead. Right? Another type of graph that we see frequently are bar charts, right? Now, bar charts are commonly used to compare distributions or to compare values within a distribution, right? Now, the principles of chart integrity and efficiency apply to the design of bar charts. You may recall that example when I was discussing chart integrity of changing the scale in a bar chart to make the differences appear bigger, using a visual lie. Make sure that you do not do that. Your bar charts may have to have integrity, and you should call out people that are not using integrity when they do bar charts. Another thing that is important for bar charts: always label the bars, right, and the values that you have. We should know what each bar represents, and also the values associated with the bars. So usually I have this, right? I get this. We see this in a lot of capstone papers or research methods papers. So let's see, figure 1. It's a relative frequency distribution of gender by section. So I'm guessing here we wanted to compare how many males are in each section. I mean, show the difference in gender distribution by section. Okay. When you look at this graph, what do you see? What is the ink? Let's look at the chart junk first. Do you see a lot of repetition here? I do. You see the word male 3 times in the graph. The word female 3 times in the graph. We see absolute frequencies here and relative frequencies on the axis. This 3D stuff, it's bringing a lot of unnecessary ink. These grid lines are not really helping at all. So how could we make it more efficient? All right, we took a lot of ink out of it, right? And now we're showing just relative frequencies. Section 1 has 86% males, 14% females. Section 2 has 62% male, 38% female, and these are the N's, or the number of people in each section, right? We took a lot of numbers out, all those lines, all that awful 3D stuff, all those commas. We took these out, right? Because now we have the percentages in, so we don't need this. We don't need to be following that crazy line there, and it's really hard to see anyway. So consider taking all the junk out of your bar charts, and always, when you're looking at distributions, always go from 0 to 100, right, to avoid visual lies. Okay, another type of graph that you may be using are scatter plots, right? They're used to assess relationships between interval level variables, and of course the principles of chart integrity and efficiency apply to the design of scatter plots. An important thing that you should always remember when using the scatter plots is to always label each axis, right? And label important points, right? And important points in scatter plots usually are those outliers, right? Those that fall outside of the pattern. So let's look at an example. This is a scatter plot looking at respondents' GPA, and the math course is taken last year. This is hypothetical data. I just made this up. But let's look at this one. We see this distribution. You see a point there. There's a lot of color here. Those are triangles that have shades and have different color of border. You have all these, grid lines, and most importantly, you have a lot of this wasted space in the graph. All these lines are not adding anything to the chart. They really are not adding anything. There are no I don't know which one GPA is, right? Because it's not labeled. This is a horrible scatter plot. It looked nice at the beginning, but it really has a poor design. No, it's not really showing much. Now consider erasing all of the chart junk from this scatter plot and get something like this. So what I did is change the scales, right? From 1, and this one is starting from 0.8. So the scales are starting from the lowest points of X and Y. This is GPA. It goes from 0.8 to 3.8. This is the lowest value and this is the highest value. Math courses, they go from the lowest value, from 1, to the highest value, 5. Now, I took a lot of the color out, and we don't really need the grid lines, right? The purpose of this scatter plot in particular was to see if there was a pattern, right? So we don't need to label all the points or know exactly where they fall. Now, some of them, the outliers, you need to point out. This one has, right, 3 courses taken and a GPA of 0.08. This is clearly an outlier, and we are labeling it. There. We took a lot of the chart junk out of it. We correctly labeled it, and we end up with a lot nicer scatter plot. Okay, so that's it for now. These are the 3 types of charts that we commonly use. You know, once you've done this, once you finish the chart, always ask yourself, do I have much, chart junk in my graph? Am I using more ink than I need here? Can I erase some ink and still convey the same message that I can? If you can erase something, erase it. That will make your chart more efficient. And also, when you finish a chart, ask yourself, am I lying here? Am I omitting data? Am I quoting the data out of context, or am I using a visual lie here? If you are, you have to redesign your chart. Thank you for watching, and next time you look at a chart anywhere, the newspaper or an article, remember these principles, and I assure you there's a lot of chart junk out there. Thanks for watching.